Section 3.5. How are Cp and Cv related? Cp minus Cv is equal to Tv beta squared over kappa. Beta is 1 over V times delta V over delta T when pressure is constant. Kappa is negative 1 over V times delta V over delta P when temperature is constant. So if we divide both sides by the number of moles, we have this equation: Cpm minus Cvm equals T times Vm times beta squared over kappa. This equation is more useful because Cpm, Cvm are both intensive properties. Vm is also intensive properties. Therefore, this equation contains no variable that depends on the size of the system. Let's look at one numerical example. Let's compute Cpm minus Cvm for copper. What we need to know is the beta value and kappa value. Also, we need to know the molar volume. The density is given to us, but then we can use this information. 1 mole copper weighs 64 grams, and we can convert this to volume. It's going to be 8 milliliters, and therefore 1 mole copper has a volume of 8 milliliters. The molar volume is 8 milliliter per mole for copper. So Cpm minus Cvm is simply Tvm times beta squared over kappa. We plug in all the numbers, we get 0.86 joule per mole K. That's the difference between Cpm and Cvm. And remember this, Cpm is always greater than Cvm. Now another example problem for water. Let's look at water at a low temperature. This is 0.01 degrees Celsius. And if we look at the value of beta and kappa, you'll realize that beta is negative. Okay, so beta is always positive with one exception, that's water, between 0 and 4 degrees Celsius. However, we see beta squared here, so it doesn't really matter. Cpm is still greater than Cvm. You plug in all the numbers, the temperature, the molar volume of water, the negative beta value, it's squared, and the kappa value. Look, kappa is 5.1 times 10 to the power of negative 5 per bar. So 1 divided by bar is 1 divided by 10 to the power of 5 pascals. So you need to have 10 to the power of negative 5 here. All right, so 1 bar is 100,000 pascals. Therefore, 1 over bar is 1 over 10 to the power of 5 pascals. Therefore, this number should be 10 to the power of negative 5 times the reciprocal of Pascal. So anyway, if we do the calculation, we get a positive number. Cpm of water is greater than the Cvm of water, between 0 and 4 degrees Celsius. Cpm minus Cvm of liquids or solids is not always small. For methanol, it's actually 22 joule per mole K. It's about 3 times the ideal gas constant. For benzene, benzene has a very large molar volume. For benzene, Cpm minus Cvm for benzene is 41 joule mole K. It's roughly 5 times the ideal gas constant.